All right, we're going to try to graph some logarithmic functions here. Our goal here really is to only identify the 2 points that we need to graph, and then we can connect the dots for a curve. Okay, we have a logarithmic function here. It's the log of x to the base of 3. So first we want to find our asymptote. We want to set the argument x equal to 0, and of course that means x is 0. So the asymptote here is x equals 0. And of course we know that the range, R, is always the set of all real numbers, negative infinity to positive infinity. Finding the asymptote of x equals 0 means that our domain is defined now. The lower limit would be as x approaches 0, and the upper limit is infinity. Okay, and we always graph 2 points. We graph our anchor point, and then we also graph the base and 1. So what we're doing is we're graphing 2 of the exponents. We're graphing the exponent when the log equals 0, and if it's not transformed, the log, the argument is always 1. When the exponent equals 0, then whatever the base is, the number will equal 1. The other exponent we're going to graph is the exponent of 1. And whenever your base is to the first power, it does equal that base. This is base 3, so we're going to graph these 2 points, 1, 0, and 3, 1. So I go over here, start at the origin, we go to the right 1, and we don't go up or down. And then we go to 3, 1, which is our base 1. And now we just connect the dots. Remember, the asymptote is x equals 0, so we do not cross the y-axis. And y gets infinitely small as x is very close to 0, and then y, or the exponents, get bigger and bigger. And as the exponents grow, because our x values are greater than 1, our base is greater than 1 here, your y values will grow and your x values get larger. All right, so that's our first graph. Now down here in example 2, we have a transformation. We are going to find everything we found first. Of course, for number 2, we know that our range, of course, is the same as the first example. Negative infinity, positive infinity, that never changes. Our asymptote does change, though. Now we have to set our argument, x minus 2, equal to 0, and when that is equal to 0, of course, x equals 2. So that's our new asymptote at x equals 2, and so we do a little dotted vertical line at x equals 2. Okay, and that also now tells us that our domain, I can change this real quick, for this new function is to infinity. And I'll change this for our current function. X equals 2 is the new asymptote. All right, and I want to graph those 2 points. Of course, we are going to change them because they are translated. Since I'm going to go ahead and put a temporary dot, I'll make that a green dot, right here, once again at 0, 1. And then the other point we're going to graph would be the base, which is still 3, and 1. But we know that this can't be true because already our asymptote is x equals 2, and we see that already we're behind the asymptote. So when we have minus h here and plus k here. Our minus h value is 2. That means we go 2 units to the right. And then our k value is 3, and we go 3 units up. I'm going to change colors here. So I'm just going to take this anchor point and move it 2 units to the right, 1, 2, and I'm going to go 3 units up, 1, 2, 3. I'm going to move the other point in the same transformation, 1, 2, 1, 2, 3. And now, those are my points. My asymptote is the same. I connect the dots with a smooth curve. And that's how we do a transformed function. All right, let's go to the next page. And I'll increase this a little bit. All right, so now we have a negative log function. That means everything is going to turn upside down. Any y values we had before will be the opposite. So the entire function is going to flip over the x-axis. So once again, we know that our range is the same. Negative infinity to positive infinity. Never changes. We want to find our asymptote, so we're going to set this argument x minus 1 equal to 0. And of course that means that our x is equal to 1. That is our asymptote, and that's where we're going to draw that vertical line right down there at x of negative, or x of positive 1. Not a very straight line, but that's what I meant to do. Okay, so since x is 1, that means our lower limit is 1 and to infinity here. All right, now we want to graph those 2 points again, 1, 0. I'll switch the color again. And this is base 5, so we'll graph base 5, 1, 2, 3, 4, 5, and up 1. Okay, now here's the trick. We have a negative. So, first we're going to translate these. So it's 1 to the right, 1 up. Let me switch colors. 1 to the right, 1 up. And then I'll take this other dot, 1 to the right, 1 up. And now I apply the negative value. It's positive 1 for a y, so now it's a negative 1y. Was a positive 2y, now it's a negative 2y. And those are my final dots. I'll erase all the other ones to eliminate confusion. Of course, the asymptote is still at x equals 1. And it's upside down because of the negative. And here we go. So I'm going to go down and connect with a smooth curve. Okay, remember it flipped over the x-axis because of the negative y. Okay, we've got one more to do. This time we have a base that's a fraction. And remember when we had exponential functions and we had a base that was a fraction. Then we had a decay function. And that's kind of what happens here. Normally we would have, you start off, remember, with negative values for extremely large negative values for y. When you have bases that are between 1, greater than 1, and larger. But now we're going to start with, it's going to be turned upside down. We're going to have very large y values coming down and then out because we have a base that's between 0 and 1. So it changes just like exponentials change. Okay, so of course our range never changes. It's negative infinity to positive infinity. X, the argument is x, therefore our asymptote is 0. And we're going to have a translation of negative 3, so we're going to go down negative 3. So first I'll go ahead and graph the points as if they were not translated. I'm going to graph once again 1, 0. Then remember I'm going to graph the other exponent. We've graphed this exponent at 0. The next exponent is 1. When the exponent is 1, that means the argument is the base. This base is 1/2. So I go to 1/2, which is the base, and up 1. And there we go. So as you see, we're going to have really large y values starting out, and then it's going to go down. Now I need to drop the whole thing 3 units because we have a minus 3k. I'll change colors here, and we're just going to go down 3. 1, 2, 3. That's my anchor point. Then I'm going to drop this other point down 3, so it's 1, 2, 3, and right there. I'll erase my original points before I did the translation. Now I'm just going to connect the two dots, and we have this logarithmic function. Because it's a fraction, we have opposite values. And there you have that. I hope that helps. We're going to flip the classroom tomorrow. Be ready to come into work. We've got a lot of great graphs for you to create.